Good afternoon students. Welcome to the mathematics class. In this class you will learn about the chapter fractions and decimals. Today I will discuss how to convert the given unlike fractions into like fractions and comparisons of the given fractions. So let's begin with the question that convert the fractions 5 by 6, 7 by 9, 11 by 12 into like fractions. These are the unlike fractions because their denominators are not same. Now first we find the LCM of the denominators of the given fractions. Then we convert the given fractions to equivalent fractions with the denominator equals to the LCM of the denominators of the given fractions. So these two steps we will follow to convert the given unlike fractions into like fractions. So let's begin with the solution of the given question. So let us first find the LCM of the denominators of the given fractions. Here the denominators are 6, 9, 12. So LCM of 6, 9, 12 first we will find. So here in the first row we write 6, then 9, then 12. All are multiple of 3, so we divide by prime number 3. So it will come 2, then it will come 3, then it will come 4. As 2 and 4 are multiple of 2, so here we take the prime number as 2. We divide 2 with this 2, it will come 1. As 3 is not divisible, so simply we write the number 3 and here it will come 2. As in the last row, both the numbers are prime numbers. So we stop our calculations here. No further calculation is required. So the product of the numbers in the last row and the divisors is the required LCM. So we write the product 3 multiplied by 2 multiplied by 3 multiplied by 2. 6 6 are 36. 6 6 are 36. So 36 is the LCM of the number 6, 9, 12. Now after that we convert each fractions into equivalent fractions having denominator as the LCM. So here LCM is 36. So we have to convert each fractions to an equivalent fractions whose denominator is 36. So first we write 5 by 6. Here 6 is the denominator. So one thing we can do here, that by 36 we divide with 6. So here we are getting 6. So if we multiply the numerator and denominator by 6, we get the denominator as 36. So multiplying with numerator and denominator by 6, we get here 30 by 36. Similarly, the next number is 7 by 9. So here we divide 36 by 9. We are getting here 4. So we multiply 7 by 4 and 9 by 4. So this will come 28 by 36. And the last number 11 by 12. Again if we divide 36 by 12, we are getting 3 as the quotient. So here we multiply 11 by 3 and 12 by 3. It will come 33 by 36. So the three fractions we are getting here, that is 30 by 36, 28 by 36 and 33 by 36. These three fractions all having the same denominators, that is 36. So these three fractions are like fractions. So these three fractions are like fractions. From these examples, it is also very clear that when the denominators are same, we can easily compare their numerators. We can easily compare the given fraction. So from this also we can easily find out that which fraction is greater. Here 33 is greater than 30 and 28. So 33 by 36, that means 11 by 12 is the greater fractions out of these three fractions. So when we want to compare any given fractions, that time first we try to make convert the given fractions with like fractions. That means we have to make all the denominators same. Let's see another important method, comparison of fractions. If the given fractions have same numerator, then the fractions which has the smaller denominator represents the greater fraction. So in this case, when the fractions are given, we have to compare which one is greater or which one is smaller. So for that case, if the numerators are same, then we check their denominators. The smaller denominators will be the greater fraction. So in this case, 5, 4, 2. In this three denominators, 2 is the smaller one. So 3 by 2 is the greater fractions. Again, between 5 and 4, 4 is the smaller one. So 3 by 4 is the greater fraction as compared to the 3 by 5. So in this way, we can easily compare when their numerators are given same. Come to the another important rule, that if the given fractions have the same denominator, then the fractions which has greater numerator represents the greater fractions. For example, when the given fractions have the same denominator, in this case, in the previous case, it was numerator and here it is denominator. In that case, we just compared the numerator. So the fractions with greater numerator will be the greater fraction. So here 2 is smaller than 3 and 3 is also smaller than 4. So 4 is greater than these two fraction numbers. So that means 4 by 5 is greater than 3 by 5 and also 2 by 5. So in this way, we can easily compare the fractions when their denominators are same. Let us see another important method, comparison of fractions by cross multiplication method. When two fractions, that is a by b and c by d, are given, then a by b is greater than c by d if and only if product of AD is greater than product of BC. That means if product of AD is greater than BC, then we can say that A by B is greater than C by D. And if A by B is greater than C by D, then we can say that AD is greater than BC. The next one, A by B is equals to C by D, implies and implied by AD is equals to BC. And A by B less than C by D if and only if AD is less than BC. Let's see one example, compare 3 by 5 and 5 by 8. Here we will do the comparison by cross multiplication method. So here we cross multiply the given fractions. So first we multiply 3 with 8. What we are getting here? 24. And second, 5 with 5. So here we are getting 25. See, here 24 is less than 25, which implies that which one is less than? Here this side is less than, that means 24 is less than 25. That means 3 by 5 is less than 5 by 8. This is by which property, which rule? This one by this third one, that A by B less than C by D implies and implied by AD less than BC. So here AD means 3 into 8, that is AD. This is your AD, that is coming 24, and BC means 5 into 5, that is coming 25. So here AD is less than BC, that means 3 by 5 is less than 5 by 8. So any of the questions we can try with this method when two fractions are given. We can easily compare with this method. Let us see another type, comparing more than two fractions. When more than two fractions are given, that time we convert the given fractions to equivalent fractions. So with the denominators equal to the LCM of the denominators of the given fractions. So let's begin with the question. Arrange the fractions 2 by 9, 2 by 3, 8 by 21 in ascending order. So first step is that we have to find the LCM of the denominators. So LCM of 9, 3, 21. So in this case, we find the LCM. First we divide with 3. Then no other. Only the prime factors is left. So we stop here our calculation. So LCM will come is equals to 3 multiplied by 3 multiplied by 7. That means 9 sevens are 63. Now we convert each of the given fractions to equivalent fractions. So 2 by 9 is equals to 2 by 9. Then here we divide 63 by 9. So we are getting 7. So we multiplied here by 7. It is coming 14 by 63. Next number is 2 by 3. So here we multiply by which number? Divide 63 by 3. We are getting 21. So here we multiply by 21. That means 42 by 63. And the last number is 8 by 21. So here we multiply by which number? If we divide 63 by 21, we are getting here 3. So multiply by 3. So here we are getting 24 by 63. So in these three numbers, we are getting the same denominators, that is 63. So we can easily compare the numerators because their denominators are same. So here the smaller numerators is 14. The next smaller 14 is the smaller one. The next one is 24 and the next one is 42. So here 42 is the greater number, then 24, then 14. So we can write it here as 14 by 63 is the smaller number fractions, then 24 by 63, then write 42 by 63, which can be also written as which number? 14 by 63 means 2 by 9. That is 2 by 9 is less than 8 by 21, and then it is less than 2 by 3. In this way we can do. Let us see an example. Rohan solved 3 by 7 part of an exercise while Ramu solved 2 by 5 of it. Who solved the lesser part? So part of an exercise solved by Rohan is equals to 3 by 7 and part of an exercise solved by Ramu is equals to 2 by 5. So in this case, first we compare which fraction is greater, 3 by 7 or 2 by 5. So let's start with the comparison of these two fractions. 2 by 5, we can compare these two fractions by cross multiplication method. That means, so 3 multiplied by 5, it is coming 15, and 7 multiplied by 2, it is coming 14. So 15 is greater than 14. That means 3 by 7 is greater than 2 by 5. So that means the part of an exercise solved by Rohan is greater than part of an exercise solved by Ramu. So Ramu solved the lesser part. Now this comparison we can do in another method also. Let us let us find the LCM of the denominator. LCM of 7 and 5. This is coming here 35. So we can write here 3 by 7 multiplied by 35. It is coming 15. And 2 by 5 multiplied by 35. It is coming 14. So we are getting 15 from 3 by 7. And here we are getting 14 from 2 by 5. So that means 3 by 7, as 15 is greater than 14. So that means 3 by 7 is greater than 2 by 5. So from this, that means 3 by 7 is greater than 2 by 5, which indicates that Ramu solved lesser part of an exercise as compared to Rohan. So who solved the lesser part of an exercise? Ramu solved the lesser part of an exercise. In next class, we will discuss more questions related with this chapter. I hope all of you understood the methods which is discussed here. Thank you all of you.